Chapter 5, Section 8 deals with fractional coefficients, and we're still continuing to finish off standard number 7, but also beginning to start standard number 15, and again just the portion in red, not blue. Whether an algebraic statement involving rational expressions is sometimes true, always true, never true. When we are solving equations that have fractional exponents, first find the least common denominator. Second, multiply both sides of the equation by the LCD. Doing this gives you an equivalent equation that does not have any fractions. And then third, solve your equation, and fourth, check your answer. So here's our equation. X squared over 2 equals 2x over 15 plus 1 over 10. To find the LCD between 2, 15, which is 3 times 5, and 10, which is 2 times 5, it's going to be 30. So what we want to do is to take the entire equation and multiply it by 30. So 2 and 30 cross reduce or divide to give us 15x squared. 30 times 2x over 15, the 30 and the 15 divide to 2 times 2x, which is 4x, and 1/10 of 30 is 3. So what we have now, we found the LCD, which was 30. We multiplied both parts of the equation by that. We have the equivalent equation without any fractions. We're down to step 3, which is to solve the equation. So let's put everything on one side and nothing on the other side by subtracting 4x from both sides, subtracting 3 from both sides, and it looks like something we've done before. We need to factor the left using trial and error to 3x plus 1 times 5x minus 3. We have the zero product property, which says that we're going to set each factor equal to 0. We're going to solve each one. So if 3x plus 1 equals 0, adding 1 to both sides, 3x equals 1. And dividing by 3, x equals negative 1/3. On the right, we add 3 to both sides, so 5x equals 3. Divide by 5, x is 3/5. So my two solutions are x equals negative 1/3 or x equals negative 3/5. Alright, this works whether we have equalities or inequalities. Let's, for example, number 2, find out the LCD, which we can probably do in our head as 24. Multiply the entire inequality by 24, purpose being to find an equivalent equation or inequality, in this case without any fractions. So 8 divides into 24 3 times, leaving me 3x. 3 divides into 24 8 times, so I have to distribute that out to x minus 2. 6 will divide into 24 4 times, which I'll distribute out to x plus 1. And 1 times 24 is 24. Much easier to consider when we don't have any fractions. Distributing out the 8, negative 8 gives me negative 8x plus 16. Distribute out the 4 gives me 4x plus 4. Let's simplify. 3x minus 8x is negative 5x. 4 minus 24 is negative 20. Let's get all the x's together on the same side of the inequality, so we'll subtract 4x from both sides. Negative 5x minus 4x is negative 9x. Let's subtract 16 from both sides, so negative 20 minus 16 is negative 36. And dividing by negative 9 changes the direction of the inequality. Remember, when you divide an inequality both sides by a negative number, changes the greater than to the less than in this case, and x is less than or equal to 4. That's my solution set. Alright, let's try a word problem. Machine A can complete a job in 10 hours. Machine B can complete the same job in 14 hours. Machine A started working on the job at 10 a.m. Machine B joined in at noon, working together on the same task. How long did it take to finish off the job? Well, a work chart helps us out. Machine A, machine B, work is equal to rate times time, just like distance equals rate times time. How much work does machine A get done, or what's its rate per hour? If it can do the whole job by itself in 10 hours, its rate per hour is 1/10 of the job. Machine B, if it can do the whole job by itself in 14 hours, its rate is 1/14 of the job per hour. Time-wise, machine A started first. Let's just call that T. Machine B joined in 2 hours later, so it's working on the job 2 hours less, so that's t minus 2. How much work did each one do? Well, the word problem doesn't tell us, but the chart does. Work is equal to rate times time. So 1/10 t, or t over 2, is how much work machine A does. 1/14 of t minus 2, or t minus 2 over 14, is how much work machine B does. What is our equation? Well, our equation comes from the amount of work that machine A does, t over 10, plus the amount of work machine B does, t minus 2 over 14, equals one job that they're working on together. Once we have our equation, we can forget the words momentarily and solve it. Find the common denominator, which is 70. Multiply everything in the equation by the LCD. So 10 and 70 reduced to give me 7t. 14 and 70 reduced to give me 5 that I'm going to distribute to t minus 2. And 1 times 70 is 70. Continuing on to solve the equation that doesn't have fractions. Distribute out the 5 to get 5t minus 10. Simplify the t's, so 7t plus 5t is 12t. Add 10 to both sides, 12t is 80. Divide by 12, and it takes time is 6 2/3 hours. Did we answer the question? How long did it take to finish the job? Yes, it took 6 2/3 hours. They did not ask for what time of day was it done, just how long, and that's time. Alright, let's look at another kind of situation where we can use a chart and use these skills we have with fractional equations. Here's a traditional mixture problem. A nurse wishes to obtain 800 milliliters of a 7% solution of boric acid. To do that, she's going to mix a 4% solution and a 12% solution together. But how much of each should she use? Well, here's the chart. The amount, or milliliters of solution, X, the percent of boric acid that it contains. When we multiply those two together, that's what the X is for multiplication, we get the amount, or milliliters, of boric acid in the solution. We have our 4% solution we're starting with, 12% solution we're starting with, and our final mixture, which is the 7% solution we're ending with. To fill in the charts, X, don't know how much of the 4% she should add. How much of the 12%? Well, she wants 800 milliliters total. So 800 minus how much of the 4% we used, that's how much of the 12% she should use. And of course, we want to end up with 800 milliliters of the 7% solution when all is said and done. The no-brainer part is, what percent of boric acid does the 4% solution have? Well, 4%, which we write as a decimal is 0.04. Remember, percent means out of 100. So 4 100ths. The 12% is 0.12. The 7% is 0.07. And if we multiply these together, that'll give us the milliliters of boric acid in each solution. So what we have here is 0.04 times X. We have the 0.12 distributed to the 800 minus X. And we have the 0.07 times the 800. Now we've got our charts. Sometimes we have trouble seeing the equation, so maybe a picture will help. We're starting with a certain amount of 4% solution. We're adding, and we're starting with X amount of 4% solution. We're adding to that a certain amount of 12% solution. Well, that happens to be 800 minus X is how many milliliters. And when we add them together, mix them together, we're going to end up with a 7% solution where we want 0.07 times 800. So that's going to be our equation coming from this last column in the chart. 0.04 times X plus 0.12 distributed to 800 minus X equals the 0.07 times 800. Our book realizes we're not using calculators. They're suggesting that it might be easier if we didn't have any decimals. So if we multiply everything by 100, that'll remove our decimal places. So that'll move the decimal over to 4x, move this over to 12, move that over to 7, and we can simplify this equation. So 12 times 800 is 9600. 12 times negative x is negative 12x. 7 times 800 is 5600. 4x minus 12x is negative 8x. Let's try to get that by itself by subtracting 9600 from both sides. So 5600 minus 9600 is negative 4000. And if we divide by 8, negative 8, x is 500 milliliters. Did we answer the question? Well, x represents the 4% solution. What was the question? How much of each? So the 4% solution alone does not answer the question. We also need to say how much of the 12%, and that was 800 minus x. 800 minus 500 is 300. So we had 500 milliliters of the 4% solution, 300 milliliters of the 12% solution. And that's our look at fractional coefficients, also including some traditional word problems.